Algebra 1, happy Tuesday. I hope you had a great weekend. What's the highest you've ever seen a water balloon go up in the air? We're going to be talking about water balloons today, so let's get started. Last week we were reintroducing something called standard form of a quadratic, otherwise known as a parabola, and that's ax squared plus bx plus c. One of the most important points of a parabola or a quadratic equation is the one at the bottom of the hill or the top of the hill, which we call the vertex. And here's how you find it. Here's how simple it is to find the vertex. Whatever your equation is, all right, you'll know there's a number for A, B, and C. Step one is to take the opposite of whatever B is and divide it by 2A. You can use a calculator. That'll give you the x coordinate of the vertex. The point at the bottom or the top of the hill is like an xy coordinate. Here's how you find the x coordinate. You take the opposite of B and divide by 2A. Pretty simple. Then step two, after you have your x coordinate, you take that number, let's pretend it's 5, and then you just plug it in for x to whatever your equation is. Make sure to protect it with parentheses. Put parentheses around it when you plug it in. So plug in x, use a calculator or your brain to find out what y is, and that tells you how high or how low the graph can go. Here's an example in our book of what we'll be doing in our homework today. We got some water balloon dudes right here with a launcher. Anybody got a water balloon launcher at home? It's been hot lately, might be fun to have. Throw some in the air. They gave us an equation of the first water balloon that flew in the air and hit the ground. They gave us a picture of the second water balloon that flew in the air and hit the ground, and they're asking us to find out which water balloon went higher. In order to do that, we're gonna need to know that's right, the vertex for each one. It looks like on the graph that this is about maybe 125, 135 feet in the air or so. That's a prediction. But for the equation of the first water balloon, we've got to use algebra to find it. So let's find the vertex. So here's the equation of our first water balloon, okay? And we want to find the vertex. So we're looking for essentially the xy coordinate. Instead of using x and y, they have t for seconds, and they have like an h for height, okay? So we want to know how high the water balloon was up in the air. So step one, I'm using x and y, the opposite of b over 2 times a. Well, a is negative 16, b is 80. The opposite of 80 is negative 80. All over 2 times the a value, and the a value is negative 16. I put a Desmos calculator on the Google Classroom, which is really easy and nice to use. It's just like the yellow ones we had in class. So when I type this in, I end up getting 2.5. That represents how many seconds the water balloon was in the air until it reached its maximum height. So to find the maximum height, to find how high the water balloon went, I need to take 2.5 and then the second step is plug it in for x. In this case, we have the letter t. So we have negative 16 times 2.5 squared. Notice how I'm protecting it with parentheses. Plus 80 times 2.5 plus 5. Again, I can type all of this into my calculator, which is really nice, and I get my answer, which is 105 feet. So right here, our vertex is at 2.5, 105, which means it took 2.5 seconds for the water balloon to reach 105 feet in the air. That's the maximum height. Obviously, if the second water balloon was around a 130, the second water balloon went higher. But as a follow-up question, if we have a water balloon and the highest it reaches is 105, and it took 2.5 seconds to get there, I'm curious. So here's the halfway point. How long was the water balloon in the air total? Yeah, I think you're right. So if it took 2.5 seconds for it to reach the maximum height, that means it would give us another 2.5 seconds for the water balloon to hit the ground and splat, which means it's in the air for a total of 5 seconds. These are the types of problems that we're going to be doing today, and here's where we're going to do them. Our assignment this week is on page 437. There's a Desmos calculator on the Google Classroom that can help you with these problems. One's about fireworks, One's about a horse jumping in the air. We've got a bridge here, and then we have an airplane hanger modeling a quadratic function. So let me know if you need help. I've got office hours today from 1 to 2 p.m. Guys, have a good one, and we'll see you next time.